Think about the intense heat inside a dying star, the crushing pressure at the center of the Earth, the microscopic flow of blood through your veins, and the massive steel grid of a sprawling modern city. These four environments could not be more physically different in scale and function. Yet, the physical structure of every single one of them relies entirely on the exact same material. That material is element 26. We usually interact with it as a basic, everyday construction material, iron, but its origin makes it a cosmic building block. What defines iron is its specific atomic structure. Deep inside its nucleus, every single iron atom contains exactly 26 protons. That precise number is what dictates its physical behavior. This atomic configuration places it squarely in the transition metal block of the periodic table, making it highly versatile, dense, and capable of forming incredibly strong bonds. To understand how we construct our tallest buildings and how our own bodies stay alive, we have to trace this single element backwards, billions of years into deep space. Long before our solar system existed, massive stars operated as immense cosmic forges. Over millions of years, the intense heat and pressure inside these stars continuously crushed lighter elements together to create heavier ones through nuclear fusion. But this process hits a strict limit when a star starts fusing element 26. Iron absorbs energy rather than releasing it, which rapidly destabilizes the star and triggers a sudden, catastrophic collapse. That collapse results in a supernova. The massive explosion violently ejects the newly forged iron out into the surrounding vacuum of space. When the early Earth was forming from a chaotic swirl of dust and rock, it collected huge amounts of this scattered cosmic iron. Because iron is so dense, it sank straight through the molten rock, pooling at the very center of the young planet. Today, a massive portion of that iron exists as a swirling liquid in the Earth's outer core. The constant churning movement of this molten metal acts like a planetary dynamo, generating a vast electromagnetic field. This invisible shield extends far out into space, actively deflecting deadly solar radiation. Without that deep reserve of liquid iron, the surface of our planet would be entirely lifeless. Biology eventually found a way to use this cosmic material, integrating it into the very machinery of life. Your body uses element 26 to synthesize hemoglobin, the protein in red blood cells that grabs oxygen and transports it throughout your body. Thousands of years ago, early humans began pulling the same element out of the ground, heating and hammering raw ore to shape primitive tools. During the Industrial Revolution, engineers learned to manipulate iron's chemistry by adding small amounts of carbon. This created steel, an alloy with the durability and tensile strength to handle loads that pure iron never could. Mastering steel gave humans the ability to build vertically. It provided the unyielding frame required to construct massive bridges, railways, and the towering skeletons of modern skyscrapers. The heavy metal that was forged in the death of a star is now pumping life-giving oxygen through your veins, while simultaneously serving as the unyielding physical skeleton of our cities. However, for all of its structural strength, element 26 has a fatal chemical flaw. It is highly reactive. When iron is continuously exposed to ambient moisture and air, it undergoes corrosion. The metal begins to oxidize, slowly breaking down into brittle, flaking rust. The exact same element, oxygen, that iron flawlessly binds to and carries through our bloodstream, is the exact same element that slowly eats away at our infrastructure. Because of this reactivity, we are locked in a continuous struggle against decay. We have to constantly apply protective chemical coatings, paints, and specialized alloys just to stave off the inevitable oxidation of our bridges and buildings. Element 26 exists as a transient cosmic traveler, a borrowed material destined to eventually break down and return to the environment. But while this metal framed our past, the specialized technology of our future relies on what comes next, element 27, cobalt.